Now the questions that's come into our mind, how to choose a right hyperparameter. Till now we have used the hyperparameter mean points and epsilon. Okay, these two hyperparameter we have used in the DBSCAN algorithms. But the questions comes into our mind how to choose. Questions that's come to our mind how to choose it. Which one is the right, which value it would be the right value for the each hyperparameters. So how to choose the right hyper to choose a right hyperparameter. The general simple concept. Let's see. Okay, let's see. So first, let's see step by step. First, we will see the hyperparameter mean point. How to choose the mean point. Okay. So, so there have in general there have various of the techniques, but in these discussions we will mainly discuss three techniques. So the first one is the first one. The first one is the general rule of thumb. The engineers, the scientists, taken the mean points, number of mean points as hyperparameter. It's depend on the dimensionality of our data set. Means how much dimensions of our data set have. The rule of thumb in general, rule of thumb, rule of thumb is the minimum point that we have used uh, as a hyperparameter mean points. The number of mean points must be greater than is equals to d plus 1. Means here d is simple. Here d is the dimension of our data set. Suppose let d is the data set and the d is the data set and xi is the data point of this data set. So here xi must be a d dimensional. If the data point is a d-dimensional data set, then in those cases, we will in generally choose the mean point. It must be greater than 2d plus 1, the rule of thumb, typically. So in general, this is the rule of thumb. Means at least we have to choose d plus 1. Okay? But typically, we have seen that. But typically, we have seen that the mean points, the value of the mean points is approximately equals to 2 into t, 2t. Typically, we have seen this kind. Okay, this is the first technique. First technique the engineers have. Second, second one is the larger mean point. Okay, suppose it's depend on the means how much quality data set we have. If in our data set there have more noisy point, then in generally we will choose the large mean points to remove the noise points, to remove the noise point. Okay, so in generally if our data set, if in our data set, if is in our data set is more noisy, if d is more noisy, then typically we choose a larger mean point. And we choose a larger mean point. Larger mean point. Okay, so so This is the means larger means I'm talking about in the sense that situations on the how much noise we have in our data. Okay, that's the thing that that's we have to in this, and according to the noise we have to choose this minimum. Means typically we have to choose a larger one. So it is the in general rule of thumb. In general cases, we have to choose this type of data. But if the in our data have more noise, then we have to choose the mean point. Means I'm talking about only mean points means mean PTS. Okay, larger mean this type of. Yep. So, so let's try to understand this concept through a picture. Suppose suppose let's take our data set have more noisy point. Means suppose it's a point in our data set. So the according based on this point, according based on this point, if we call this point be a 4 point, if the radius epsilon based on some radius epsilon, we'll see how to choose the correct right right radius. We'll see these things. We'll let this is based on some epsilon radius. We'll choose this region, and these are the some noise points here. If we choose the this epsilon as the larger, that means this one is one these points that are more less dense. If we choose this, we choose epsilon is larger, that implies the region less dense less dense. In such scenario, what we have to means what we have to do in such scenario means to remove this noise point. To remove this noise point in our calculations, we need to choose this much. How much we have to choose in our data set. So suppose let these are the very small digits, small dense type. If we choose for this point, if we choose this, the epsilon is larger, then for this point that will make a single cluster. Okay, but for this point, this point have not included for this point. So in such cases, in such scenario, it is possible. Sometimes it is possible to remove remove this kind of noise points from our data set. It's help us to remove it helps us to remove a noise point. Okay, I think you got the answer. Now let's see the third type of thing. You choose a hyperparameter. third, third method. Third method is that using the domain knowledge of the domain expert. Knowledge knowledge of the domain expert. Using the simple knowledge of the domain expert, we have to choose what will be the mean point value. Yeah. What will be the mean point value? Okay. And suppose let's take we are working such domain. So the knowledge of that of the data set. Suppose let's take we are working some data set, and these data sets are over some from some domains. Okay. So now we have to ask the domain experts how much points there may have from based on some point. How much point there may have based on some point. Okay. Just using this domain knowledge, we have to choose this type of parameter. How much does value? How much this mean point will be? How much this mean point will be? Okay. So these situations we will see when we will discuss the various kind of case studies. We will see these things in this kind of situations occurred in future also. We will or more easily we will understand how to use this knowledge of the domain, how it is useful to choose a right hyperparameter. So mainly these three type of method we have used to choose the mean point hyperparameter. To choose the mean point hyper, mainly these three. Now let's see how to choose the hyperparameter epsilon. Okay. Now let's see how to choose epsilon. So I think from these three methods you will understand somehow how to choose the mean point hyperparameters. Now see how to choose. So to choose this hyperparameter, first assume that we have already choose the hyperparameter mean point. So let we have already choose. Suppose let we have choose some value 5. We have choose some value 5. We have let, because already we have seen how to choose these hyperparameter mean points by simply using this type of concept. There have also various concepts. Suppose let's using these three methods, we choose the how much the value of hyperparameter will be the mean point. Let's show we have chosen here 5. Based on this 5 value, we have to choose the how much this epsilon value. What will be this epsilon value? Let's see. Choose the first method. First we have to measure the distances from the xi, any point xi to the means if we have choose the fifth mean point fifth, then we have to find the distances from the fifth to nearest neighbor of the xi. So we have to find the distances first. We have to find the distances from xi I'm talking about. If we find the epsilon of the point xi, then we have to find the distances from xi to the fifth nearest neighbor points of xi. Okay, that means what? Just try to understand. That means, suppose let we have the point xi. This is the xi, and we have to find. We are interested to find it. So what will be the epsilon value for this one? We have to interest to find this value. I will choose this thing first. Suppose let's take based on this point. There have some value. There have some value. There have some value. So how much mean points we have considered here? If 5. The mean points we have considered here 5. So we have to find the uh, a fifth nearest neighbor. Okay. Suppose let's take this is the first nearest neighbor. This one is the first nearest neighbor. This one is the second nearest neighbor. Right. This is the second nearest neighbor. Let this one is the third nearest. This is the fourth nearest neighbor. Let and let this will be the fifth nearest. This point will be the fifth nearest. So now first we have to find the distances from xi to the fifth nearest neighbor. Okay, that's things we have to find. So we have to find the distances from the xi's to the fifth nearest neighbor. And suppose let's take the distances each from di. So let's take this distance I di. For this xi point, this distance is let di. This distance is di. After finding this distance, next step that we have to do, we have to find for each pointed. We have to find the for each pointed for each point. Suppose let's take for first point, we have find this fifth nearest neighbor distance. So let this put this distance, we got it. Which one? Means this is it. These are the points. These are the distances from xi to the means I'm talking about fifth nearest neighbor of xi. Here I have fifth. Why I am choosing fifth? Because fifth is responsible for the mean point. Because this fifth is responsible for mean point. Suppose let's for x1 point we got this distance d1. For x2 point we got this distance as d2. Similarly for x3 point we got these distances as 3. Similarly for xn point we got this distance as dn. We got these distances for each point. Okay, after finding this distance, we have to sorting its distance. We have to sorting its distance. In distance, we have to sorting. We have to sort di's in increasing order. Okay, we have to sort di in increasing order. Okay, first the job that you have. So after sorting this, we have to use the elbow method. Elbow means one of our previous video, one of previous chapter video we will see what is the elbow method. We have already seen. Sorting this, you have to use the elbow method. Elbow method is at this type. So this is the point indexes. Suppose let's take this is the point indexes. Yeah. This is the point index, and in y-axis we use the distances. Since we have already sorting this order, we have already sorting the value of the distances. So the plot that we got here, this type of plot we got. This type of plot. You see, this type of we got. Okay. So using this plot, we have to consider what will be the right elbow value. So suppose let's take after this stage we got some constant. We got some. Okay, we got this type of after we got these pictures and we have choose this is the means after this stage, after this point we got the point is constant. not much increased. It means the value of the distance is not much. So we will choose now, we will choose this will be our right d test value. We will choose now this will be our right d test, and this value now will be our epsilon. This value will now our x epsilon value. So what means this? After this point, these points are means what? Means these are the distances for noisy. These distances. These are the distances. These are these largest distances are these are the distances for noisy point. Okay, these are the distances for, and these points are these are the noise point. Okay, this simple technique we have to use to find the right epsilon. Now let's try why these points are actually a noise point. Let's see. Suppose let these are the data points. These are the data points. These are the data points, and there's some data. Okay, these are the like of data that we have. Now from this here means for each point we have to find the distances for each if the nearest neighbor points. Based on this, we already find, and we have to sorting this. So after this sorting, since it is the already sorted, so these value are the higher DIs. These value are the higher DIs, and these are responsible for lower DIs. After some step, that means after some step, we will see these are the closed, means from each point, these the value of the each point is the less. So from each point, if we consider, suppose let's take this point, we have, if we consider, just zoom it little bit, just zoom it. Now set. Now it's better. So for this point, distances from its, suppose let's take, we find its distances from for this point. This is a little bit. Well, let's take this distance is d1. Suppose let we have considered another point, this one. This one, suppose let's take d2. Suppose let's take we have considered d3. Suppose let's take d3. These points are like that. This point I will consider d4. But if we consider this point as a d5, this point, we consider this point, I'm using the different. So let's take, I have you consider this point. If we find this distance, and these distances, suppose let's take, we call these distances as d5. Now this value will be actually d4. Then we from this picture we can conclude, we can see that, we can easily see that d1 approximate equals to d2, approximate equals to d3, its approximate equals to d4. These are the approximately equal. These values are the approximately equal. But these value d4, d5 value, most larger. These are the larger values. D5 is the most larger, because it is a larger value. Because of these reasons, we can now declare that it is a noise point. It is a noise point. We can declare because of this. So because of simple these reasons, we can We can conclude that because of simple these reasons we can conclude that for this point, for this higher distances value, these distances are responsible for noisy points. These points are called the noise point. I think why this type of graph, why we got, I think you got the answer. Because we have sorted the distance already. Because of these reasons, we got this type of, okay, and based on this value, we have to choose the what will be the right distances. Means what will be the right distance, and this distance we declare as our epsilon. I think from these discussions you got the idea. So just to recap this thing. So for finding the hyperparameter mean points, there are three. In general, there are three type of rules. The first rule of thumb is based on the dimensionality of a data, we have to choose the mean point. So the mean points are at least d plus 1. Okay, d is where our dimension of our data. Typically, we will choose the mean points is approximately equals to 2 into d. Okay, that's the first. Second, we will choose based on our noise data point. How much noise in our data set? Based on this, we will choose our mean point. Means if our data set more noisy, then we have to choose the mean points value is much larger. Okay, because this larger mean points value will help us to remove the noise point set. The third concept is the knowledge domain, knowledge of the domain expert. So by simple asking the domain experts and ask them how much mean points they will have. But there are also various kind of technique, but in generally these three techniques we have used. Now to find the epsilon value, hyperparameter epsilon, so first thing we have to decide what will be the value of our mean point. Now based on this mean point value, we have to find the distances from each point to its the mean point nearest neighbor value from this point. So here we have taken the mean point is equals to 5. So for this mean point, we have to find the distances from this point to the fifth nearest neighbor value. So for each point, we have to find such distances, and after finding these distances, we have to sorting that in increasing order. And after sorting it, we will plot it to our points index. Okay, according to our point index, we will plot it. And from this plot, we have to choose what will be our right epsilon, what will be the right d test. This will declare, this will be our right epsilon. And the higher d test, higher di's value, higher distances value is responsible for noisy point. Because of these reasons, we will omit, we have not considered these in our calculations. Okay, I think from these discussions, you got the idea how to choose right hyperparameter, means how to choose a right mean points value and how to choose a right epsilon value.